This set of 9 videotapes provides an opportunity to share in a unique experience where Stafford Beer introduces an audience to the world of managerial cybernetics. The event took place over 5 days in July 1994 at the Falcondale Hotel near Lampeter in Mid Wales. It was organised by the Liverpool Business School at John Moores University, where Stafford is Honorary Professor in Organisational Transformation and a Senior Fellow. The aim was to provide a video learning resource by recording discussions between Stafford and an audience that had little or no previous knowledge of the subject. Over the course of the event, Stafford explains the development of the subject from the initial scientific discovery of cybernetics. Through his own development of managerial cybernetics, he introduces the tools and models that he has created to offer an alternative approach to conventional management practice. The resulting material embraces the key principles and models that have previously been introduced in his 13 books and referred to in many of his published papers. This is the first learning resource where all these have been brought together in one integrated way. Managerial cybernetics continues to be the only available scientific and coherent account of effective managerial practice. Stafford provides numerous anecdotes, applications and insights from the perspective of practitioner, manager and scientist. Session 3 begins with the question of measurement and how do we choose what to measure. The measures that we already have are not necessarily relevant, as they are usually based on linear concepts and not on systemic ones. Systems are much more complicated than we think. In fact, they're usually a mess. Stafford pushes the audience to explore what would count as a measure of messiness. Ashby's definition and the use of the word variety is introduced and used as a measure of complexity. Variety, therefore, becomes the focus for this session. The consequences of using low variety models to deal with highly complex situations are discussed with examples in the economy, education, publishing and printing. This leads on to Ashby's law of requisite variety and an explanation of why so many management techniques fail to recognize what the system is and have inappropriate measures. Although the complexity of situations is often higher than we initially think, some of the complexity can be illusory. To illustrate this, Stafford leaves the participants with a problem called an exercise in what? See how they go about tackling this problem, even when there is a bottle of wine up for grabs.
I have tried to paint a picture where we see that systems are much more complicated than we thought we may have thought they were. They're non-linear. They are immensely confused and complicated. We don't know where the boundaries are. They are basically subjective. Now, this is a mess. So what are we, and we also try to establish, I try to establish that the measures we use are the ones we happen to have. Then they're not necessarily relevant and probably aren't relevant because they're based on the wrong ideas. They aren't based on causation, linear, etc., etc. So the question I left with you was, well, what could you measure? What is it we want to measure? Never mind saying, is it possible? What do you want to measure, given this mess? Have a go. Say something. It's only goodbye.
I want to measure where you are in the mess.
Well, that's a good idea, yes. But that's, again, very subjective, isn't it?
Yeah. Would it have to be something which is common to all the in the...
It would, wouldn't it? Yeah. See, spot on that. Now, money is usually used because various people, so I've managed to stop blackguarding economists so far, but it's been very difficult. They are mainly responsible for these oversimplified accounts of what things do, and for the fact that they say, well, money is the measure of all things. We can reduce everything to monetary terms. Well, I don't think you can. However, what Chris says is absolutely true, isn't it? That you need something which is capable of taking in all this mess and measuring it. Now, if it's not money, what is it? Now, you don't know yet, I'm going to tell you, but the fact is, I want you to ask yourselves the question of what would it look like? What would it have to do? And Chris gave the first answer. It has to be available to the whole thing. What else could we say about it? What is going on here that matters?
That the system works.
That the system works? Okay, that's a very teleological answer. If you look at the mess we're in, what is the measure of the messiness? Is what I'm trying to get out of you. What? Somebody said it. Yes! Thank God somebody said it. It's the complexity. We are trying to manage complexity. Now, we used to say 40 years ago in management science, we have to deal with the 4 M's: men, materials, machinery, and money. So those are the things you measured. But actually, what you were trying to manage is complexity, not these 4 things at all. They are problems and constraints and all that stuff I mentioned earlier. So we need to measure complexity. Now, how do we do that? Well, we owe the answer to this to Ross Ashby, whom I've mentioned already. He saw this with very great clarity, and he used the ordinary English word variety to measure complexity. Now, you say this has higher variety than that, you can see that that roughly means that it's going to be more complicated. But I've already told you Russ was meticulous. That's not enough. So he defined variety as the number of possible states. Now we're getting very hard-nosed and scientific, aren't we? The number of possible states of something or of the system is its variety. Now, the subject tonight is in fact variety, and I really want you to get a firm grasp on this, because it's the essence of cybernetics to me. Now, number of possible states. There's a light up there. How many states has it got? So, can't you count, Catherine? How many states? 2. 2, she got there. Yeah, great. Sure.
Just a minute, I'll consult.
Kate already got ahead of you. What did you say, Kate?
3, because it could be broken.
Oh.
Good.
Doesn't that just mean that the light is off?
It means the light's off, but it's not the states of the system we're trying to measure. Uh-huh. No, that's different, isn't it?
But it could be, there could be other problems. It could actually be broken because of the electrical static. It could be 7-state in Belvoir.
Yeah, go on. Work backwards through the system.
There could be no power.
Right. Somebody just blew up the power station?
There's been thunder.
Yeah, now you're getting it. This is why things are complex. They're not as simple as they look. Sorry, you're the full guy here, Catherine. I mean, it's so obvious it's 2, and then it turns out, yeah, just a minute, what do we actually mean here? You know, if you want to know the number of states, you're going to have to count them. And in just the way we have been doing. And before you know where you are, you've got an awful large number on your hands. Well now, let's go back to the simple thing, whether the light's on or off. We say that because there's a thing called a switch which turns it on and off. Would you believe? Some of you will have seen a stepping switch with, let's say, 10 positions on it. It goes click, 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 click. Now how many states have we got? It does indeed. You're doing very well for me, Catherine. Well, I did say that there are 10 positions, which means that the 10 intensities of light, right? So how many have we got now? We've got 10 plus off, plus as many things as Kate can think up here to obfuscate the issue. So, no, that's all right. Getting used to the idea of trying to measure variety? It's kind of weird. Not as easy as it looks.
How would you see a lot of the switches these days don't have 10 positions, they just have a continuous...
They certainly do. Well, you tell me, what's the variety of...
It's infinite.
It's infinite. Is it?
No.
You walk right into that, Glenn. Thank you very much. So this is a variable switch. You just move it, and somebody said infinite.
That depends on the perception.
Kate's winning tonight, isn't she? Because, doesn't it?
That's what
So, what do you mean it depends on perception? Don't you answer this time, make somebody else work. She said it depends on perception. What's that mean?
Perception of the system definition.
Absolutely. Well, go on.
Well, it's whether the state of being on is a measure of intensity or not.
We already said it is.
Isn't it subjective?
And now we're asking whether it's infinite. It's a very, very interesting question. Really is.
It's your definition of system steps.
Otherwise,
It's defined by 2 limits.
There's not an upper limit, right?
But someone who's got very bad eyesight may only be able to distinguish.
Never mind somebody with bad eyesight. What about somebody with good eyesight? How many states can you distinguish? It will depend a lot. Now, what have we done here? Something extraordinary has happened when you think about it, because we were talking about the light and its switch and its power generation as if it was something objective. But we've already agreed that systems are subjective phenomena. They're things we think of. So what have we added, crucially added, when we talk about your perception of the system?
Your perception.
Yes.
Individual perception.
That's getting better, you see. It's not a perception, it's just an abstract noun, isn't it? What perception? It's your perception, Glenn says. Well, of course it is. And so now we have this extraordinary thing, which is revolutionary in this thinking. It really was. That you suddenly realize that the observer is part of the system. And you can't talk about the system without this observer. Now, you see, 200-300 years of science said that there's a reality out there. We come along and measure it. If we can't see it, we invent the telescope. If it's too small, we invent the microscope. And always there's this objective reality, and I'm some kind of god with the instruments who's going to tell you what it's all about. But suddenly we see that what we are really talking about is a constantly interactive exchange between the observer and the system. Now, actually, you see, this has been discovered in physics at the turn of the century. Does anybody know what I mean?
Yeah.
Heisenberg. Anybody else know Heisenberg? The principle of indeterminacy. Heisenberg realized this, and just look how long it took to get out of, I mean, this became the physics of quantum theory, quantum mechanics. Round about the turn of the century, look how long it took to get into the system. The system. When I was at school in the 30s, Einstein was regarded as a nutter. And I remember distinctly asking a physics master what the hell relativity theory was all about. And he said, well, it's obvious nonsense, my boy. This is the 30s. Because Einstein says that parallel lines meet, and we know they don't. Period. I went away and thought about this, I mean, because obviously, in Euclidean geometry, parallel lines don't meet, and here's this guy saying they do. And nobody ever pointed out to me, I had to discover it for myself years later, that whether you think they meet or not depends on the axiomatic system you set up. And Euclid set up a system of axioms in which they didn't meet, and Einstein monkeyed around with that, and in his axiomatic system they do. So what's the big deal? The big deal is perception. See, because it's not a question of whether something called parallel lines meet. There isn't anything in nature called a parallel line, my friends, is there? You know, it's a construct that we put on it. And so what we think about it is conditioned by the way we look at it, just like the red filter. So, we are in dead trouble here, see, is what I'm trying to say to you. If we want to measure variety, we have first of all to specify what the system is that we propose to measure. And outstandingly, we have to include the observer in the loop. Now, the medieval people understood this. They had a thing called Ouroboros. Anybody heard of Ouroboros? Greek word. You may have seen the picture of Ouroboros without having heard its name. It's a snake that's eating its own tail, or two dragons which are eating each other. And this is a marvelous image, which shows us, you see, that that our whole language system and our whole perceptual system it does consume itself. And if you want to say anything, you've got to be very careful how you express yourself. Otherwise, you are into some kind of linguistic masturbation, to put it crudely. Because you're just using the language you use to do the things you do with the language you use, and then you pretend it's something to do with something outside yourself. Well, this is hair-raising stuff. Does anybody know the name of the branch of philosophy which is defined neatly as what do we know and how do we know it? Epistemology. From the Greek episteme, which means knowledge. And what I was saying to you in the last session was all about epistemology, only I didn't admit it. You see, now we're coming to grips with it. It is about what we know and how we know it. Now, if somebody comes along and says, I can tell you how the economy works, and it's like this, and these are the words we have to use to describe it, how are you going to know whether this makes sense or not, given that it is a model, given that it is low variety model, please note? in a very complex situation? Ho, ho. Do we really need a low variety model in a highly complicated situation? I should say not. How are you going to know whether it works? Well, the only answer is, of course, if you apply the nostrums of the economist to the economy, does it have any effect? Hey presto, do I need to go on? It doesn't work. No, we adopt monetarism, total disaster. So you say, oh, there's something a bit wrong with our I'm now introducing this word model more and more, because if you abandon the idea that there's a reality which we're supposed to, God is supposed to tell us about, or we're supposed to know about somehow, and substitute this notion of the observer trying to understand what the hell is happening in a very complicated situation, then it's obvious that the Robinson Crusoe kind of economics is not going to work. And if you want the proof, it doesn't. So you can be a Keynesian, you can be a Marshallian, you can be a Marxist, you can be a Friedmanist. You can do all these things, and none of them work. So one of the things I came kind of famous for was attacking the business schools for saying, see, the way I put it was, they're all teaching different things, somewhat different. The only thing they have in common, you see, is the scientific truth, isn't it? They're all teaching one thing in common. What is it? It is that none of the teaching works. It's no wonder I'm not very popular. Well now, we're really getting to grips with this thing, you know. I know it's still very abstract, and I thank you very much for hanging on to me, but I see you do. Now, we've got to get back to the counting business if we're going to could try and quantify things, and we've already seen it's not easy. You have to specify the business with the lights. Now, let's have a look at something here. Somebody tell me the variety. Good answer. Somebody can count anyway. Ah, you see, you're getting suspicious. Seven factorial, 1. Who said 1? That's very interesting.
I did.
Why?
Because, as we said, it depends how you perceive it.
Yeah.
If you perceive them all to be simple crosses,
Mm-hmm.
the same, then the variety is 1.
That's right. You say I am in a universe of crosses. Yeah, something like that. So we get V equals 1. Our next bet was V equals 7. Well, there's an obvious reason for saying that. Now, somebody already began to wonder if that was adequate. Where do you go from there?
Well, if the crosses are off states, for example,
Yes.
then that's
Yes.
where you start coming to 7 factorial.
Yes, that's right. Well, let me take a little discussion here before we get to that. See, if we're talking about a system, then we have a suspicion that this is a system, then these things are interconnected. And the question arises, how many ways are there of interconnecting 7 things? Who knows? Pardon?
Depends if you're arranged in a line or
No, it's all the possible interactions. I didn't arrange them in the line for that reason. So this is related to this essay. Pardon? 6 times 7 is the answer. It is V equals n into n minus 1. And in this case, that's 42. Now, you're all very sophisticated people, because if you weren't, you would say it was 21. Why would that be?
Too sophisticated.
See, the school books will tell you that it's n into n minus 1 over 2. Why? Because if you put that in, then you've also got that. Now, why is that wrong from a cybernetic point of view? I can't hear you,
They
Karen.
don't have to be the same.
That's right.
A with B is not the same with B with A.
Right. Ask an uncle and a nephew.
Yeah.
You got it. Isn't that so? They're not the same. So this is the sophisticated answer, and the school textbook, which says it's 21, is very unsophisticated. Now we come to Glenn's point. We've got all these interconnections, so the thing is beginning to look like this, you see, and a great mess here with 42 connections. He said maybe they're on or maybe they're off. And that's the simplest case. Now then, if these are on or off, who cares to say what the variety is of that number when any of these may either be on or off? Yes, you got it? 2 to the 42. And that's really rather a large number. And that's only if it's on or off. It doesn't take account of Kate Bailey's version of the world in which things may be on or off for all sorts of bloody reasons, which is the truth of the matter, after all. So this begins to get extremely complicated. Now, if you want to know what the variety is of any situation, it's obvious, isn't it, that you have to make a very careful statement about what it is you think you're dealing with, because the answer is going to be all over the place. And what we find in management, and I'm forced to get round to management because that's my subject, is that most people in management do not take the trouble to ask themselves what exactly they are computing with. And why do you think that management and unions never agree about anything? It is because they're talking about quite different systems with quite different varieties. And here we have this very week, we've got a rail strike going on, and they're just not communicating. And they think it's possibly something to do with politics. I don't know what they think. But I'm the cybernetician observing this lot, and I say quite simply that they're not talking about the same system. And if they were, they wouldn't know how to measure it. And I hear managers talking very simplistically about situations which, when I go and talk to union people, are perceived as infinitely complicated because of families and social life, which is being reduced to practically nothing by a management who is saying, well, you know, time and a half, or something very, very simple. Now, I've told you that I've worked in all this stuff all my life, and I'm not a theoretician. Well, I am, I guess, but it's very much based on my own life. I have had many dealings with trade unions, and I've never once had the slightest difficulty with any of them. Now, why should this be? I'm not a damn genius. I mean, I think about those things. And I want to give you one very strong example of this. The height of my managerial career was as development director of International Publishing, which at that time was the world's largest publishing company. It was run by a man called Cecil King, who was a nephew of Lord Harmsworth. It was the thing in publishing. I was in charge of research and development and the whole of computers and all of this jazz for the whole of this enormous company. Think of the date, late 60s. I was the first person in the world to launch a publishing enterprise through screens, through electronic screens. It was called the Stockbroker Computer Answering Network, SCAN, and it put into stockbrokers' offices online, real-time information, changed everything. More or less destroyed the stock exchange, by the way, but it took them years and years to catch up with that, and then we had the, I don't know, you probably remember, it's not all that long ago, when this whole thing blew out of the water, because they didn't understand it at all. So, all of this So I went to the two leaders of the trade unions. Now, they were very interesting people. Briganshaw was the key man here. It's too long ago for you to remember the name. But you see, I always start those negotiations with the belief that the other guy is a decent, sensible man, not some kind of blithering idiot who wants to destroy society, which it seems to be the way people treat this. So I said to them, look, printing has been the same for 500 years. We've just souped it up a bit. But Caxton would recognize the presses in the Daily Mirror just like that. They'd say, goes a bit fast, doesn't it? But that's all. Now, what we are going to do is we are going to scan these pages electronically. We are going to have automatic page composition. Now, by the time I was talking, we'd already got column composition. In other words, you could get a column that was right-hand justified, the hyphens and the margins being correct. Now we're talking about the whole damn page. This is rather linear. You know, although it's in 2 dimensions, it's a linear job. The whole page is a very different matter because you've got to put in the photographs and the works. Well, my lot solved the problem of automatic page composition, and you'll notice that this makes most of the printing unions redundant. So before I told my colleagues on the board about this, I saw the trade unions and I said, look what we got here. And I left the page with them, and the cleverest man in the union delegation wrote me a note saying, Stafford, the writing is on the wall, do you have to make it so bloody obvious? Isn't that nice? See, don't take this guy out to lunch and say, well, okay, what are we going to do? Now, the problem, of course, is that the unions are conceived like medieval guilds in many cases, and certainly in the printing unions. You know, you apprenticed your son, and he inherited the job, you know, and suddenly somebody comes along with a bunch of electronics and says, put away your hot metal, it's all over. So I said to them, look, it's obvious, isn't it? This is going to happen. Whether I like it, you like it, no, this is here. Now, how do we look after your members? What we have to do is train your members in electronics. That's all. Most of your kids are at school. You don't have to take them into hot metal, which is a dead loss. Let's put them into electronics. Now, I said, my company will subsidize that for you. We will give you scholarships and so on to get into electronics and take over this technology, and you'll be just the same as you are now. No problems at all about it, really. So why didn't it happen? I put that to the board of IPC, and they were very dubious because they lived like this, you know, all these years. Now, IPC was very advanced in having me there, I can tell you. Associated Newspapers, the Daily Express, and these people were not about to buy this one little bit. And the whole industry has to move together, so no one would do it. And what was the result? Years and years later, I left in disgust. We had Wapping, remember? Where a kind of embattled city is set up in the Isle of Dogs with barbed wire and policemen all around it to keep the unions out, while they're junked in favor of electronic technicians. Now, this is an outrage. It's totally unnecessary. Now, I suppose you think I'm talking politics, and I suppose I am. I can't really help it, but I'm trying to give you realistic examples of what I'm talking about. This isn't airy-fairy stuff. We are trying to absorb the variety of the situation through the latest technology, which is a way of perceiving, isn't it? You're perceiving the world either through hot metal, to simplify it, or through electronics. And if electronics is coming, then it's what you've got to do, and you stop talking this jazz that would have made Caxton laugh. So there's an example of it. Now, what you've got to do is understand the system you're dealing with. I've now added understand the technology by which you perceive it. Keep your mind open that you won't have all the technology yet. There may be other stuff coming round the corner. So you've got to conceive of practically anything. Do realize that science fiction was never more than a couple of years ahead of science fact. Practically everything that is in science fiction has happened. Men on the moon, nuclear power, 20,000 leagues under the sea. When was that written? In the 19th century by Jules Verne. Was clearly a nuclear-powered submarine. He didn't quite know it, but it had this huge furnace which never went out. Well, we got one. No wonder they called the first nuclear sub Nautilus. They recognized it. So the human imagination is followed very fast by the ability to reify it. That's a nice word. I like that word. Anybody know the word reify?
To make real.
It's Latin, res, thing. To make it a thing. Yes, exactly, Lee. So we reify our imaginations, and we are constricted only by the models we have and the variety we can handle. This is a new universe, folks. It really is. And you start looking, this is why I challenge you to look at the newspapers. Start looking at it in this light, and you will find that the arguments people are having are bizarrely unreal. They're living in a dead world. It's all over. And we have to find the new way. We have to look. Somebody here speaks Spanish, I think. It's you. Patricia. Caminante no hay camino, se hace camino al andar. Do you know this song? I'll translate it because nobody else knows Spanish anyway. Walker, there is no road. You make the road as you walk. I could give you that as a motto. It's wonderful, isn't it? Because if you follow the roads everybody's laid out, you're going to get to the same disastrous consequence. I was reminded earlier this evening, I was walking around in Israel, my only trip to the Holy Land, totally mind-boggled by everything. And I was walking in the hills outside, in the hills of the Sea of Galilee, thinking about Jesus, and I ran into a signpost and it said, Armageddon. And I thought, yes, the story of my life here. Yeah. So, here we are with our problem, and I've really tried to loosen your thinking up and saying, well, we are hanging on to the notion of variety. Now then, what are we going to do with it? You're going to go around counting things? And trying to imagine how large they actually are and trying to count. This won't do. Can't do it, But we have been taught that measurement, mainly by accountants, we've been taught that measurement is an exact science, and that if there is a penny left over at the end of the day, the entire banking staff must be kept in to find this missing penny. But statistically, of course, the penny means nothing. It's experimental error. I mean, £1 million is an experimental error in most of this stuff. So that's not the way into variety. Now, let me try and gently suggest to you what is the way in. If I got up, I don't want to because my legs hurt me. If I got up and held up a coat of rather unusual size, let's say it's very small, it's very big, and obviously, I say, I've got this coat going begging, does anyone want it? Now, how do we know who will fit this coat? Somebody might say, that's a very large coat, I am 6'5", I'll have it. Or somebody says, that's a very small coat, I'm the smallest person here, let me try it on. We say that kind of thing, don't we? So the varieties are being handled without counting, is my point. We have no problem in saying that's bigger than this, without calculating, as we've been taught we must, essentially, forgive me my accountants. If I said, I have this piece of furniture, will it go into that alcove? Unless it's very marginal, I say, yeah, it's going to go in there, or couldn't possibly. And that's the decision I want. Now, we could go and measure the alcove and measure the piece of furniture and say, well, the alcove is 3'5" and the piece of furniture is 7'6". I don't think this is going to work. We don't need to do that because we make comparative variety evaluations. And most of what we do in the real world is about that, I think. Now, if we start thinking of our problems in terms of matching varieties, we're on to a new ball game altogether. And so it's no use the minister getting up in the House and saying, we do not have the statistics for how many lesbians are running amok in Newcastle or whatever, as they do at the moment. You wouldn't... No, I didn't mean they do in Newcastle. Ministers, thank you very much. Somebody rescue me. I do get into trouble sometimes. What we say is, let us look at what we can assess. Now, when I said measure, I don't mean count, you see, necessarily. Now then, let me give you this example. Here is a scientist from Mars, who's a very good scientist, but knows nothing about terrestrial matters, okay? Now, out there, he sees a green field with white lines on it and things we call goalposts at the end. And unknown to him, a set of 11 guys is practicing. And these guys all have red shirts on. And they start off down here and they run down this field and they push a ball between each other and then somebody slams it through the posts and then they take it back and they do it again. So they score 370 goals in the time, in half an hour that the Martian scientist is observing this. So he said, well, this is very interesting. What is going on here? So somebody says to him, well, we've discovered that this is a game called soccer, and that the objective of the game is to stop these people doing that. So what do the Martian scientists say? He's facing a very high variety situation. Now, what he notices is that the ball goes back and forth and always goes like that. So the Martian scientist says, well, let us put a big slab of concrete right there. And this can't get through it. So he does that. And then down come the 10 men in red shirts and they go round it and the Martian scientist says, bloody hell, I wasn't expecting that, you see. So then he tries the strategy. I mean, just think it through from his point of view. He tries the strategy of putting a lot of little posts all over the place. And now these people who are known for their dribbling, only he doesn't know the word, they're just having a fine old time running all around this stuff and still score 380 goals. Johnny says, well, what's going on? Clearly, these individuals, these 11 individuals, are governed by their own control system. They must have something in here somewhere that tells them how to operate. We must measure that. So the Martian scientist comes along with something that we should call an electroencephalograph, and he puts it on the head of these people and says, I will try and find out what's going on in Paddy's head when he's trying to get round Chris, the concrete post. You have an easy role tonight. Now, just please follow this through. I mean, it's bloody fascinating. What are you going to do next? You get all these brain waves read out, and now you say, well, clearly they're communicating to each other somehow. How are they doing that? I don't know. So you wire all these electroencephalographs up to a computer, and you try and make a model of the whole darn thing. Now, this isn't going to work because everybody's going to fall over the wires. So now you have a huge R&D project, which is going to cost the earth, as to how you transmit by radio to the computer what's going on in the brains. Now you only have the problem of finding out the model whereby all these brains are interacting. Now, does this not have any ring of truth to you? This is how we proceed with things. Now, what is the actual answer to the problem of how you stop 10 men in red shirts scoring all these goals?
Technical customer.
Oh, there's an anarchist. What did you say? No, yeah, another anarchist. Come on, you know the answer to this.
Put another 10 people on the field.
Pardon, Dave?
Put another 10 people on the field equally matched.
They have to wear white shirts. Yeah. Exactly. Now, you have discovered Ashby's law, which I think is as important to management as the law of gravity is to physics. What is it that you have just discovered?
Much variety.
Yeah. Only variety can absorb variety. You don't have to count all these states, you have to match them. You know, suppose I wave my hands around a lot, I know it, don't take the mickey out of me. Supposing I waved them around so much you didn't know how many fingers I had. But supposing I, judicially, as a good professor, kept doing that. And you still didn't have time to count, but you would be able to say he has the same number of fingers on each hand. That is the sort of thing I'm talking about, where you're not counting, you're doing something much more sophisticated. You are matching variety. Now, all our problems arise from disobeying or attempting to disobey Ashby's law. As a matter of fact, you can't. It's a law of nature, you see. But we go around with management systems which consistently ignore this. Now, the Chancellor of the Exchequer says, well, I want to control the money supply and inflation. Then the economy is under control. What? All you're going to do is create all these people running around the goalposts, hiring hordes of accountants and lawyers. No problem. Then the Chancellor of the Exchequer is left standing there like a lemon. It's their favourite occupation, as you know. You've got a traffic policeman, stands at an intersection. The roads look like a swastika. They go like that and then turn round the corner, you see. He can't see anything. He's got a 3-mile queue down here. He doesn't know. So he's waving people on without regard to the total picture, which is our big system, holistic notion, because he doesn't know anything about it. Bless his heart, it's not his fault. And what I am suggesting to you, and it's mind-blowing, I think, is that all our management techniques fail to recognize what the actual system is, can't measure it because they're using the orthodox measures, don't understand the law of requisite variety, move in there with a crowd of glowing stuff and say, this is what we'll do, then it doesn't work. So what do they do next? Mrs. Thatcher was the great exponent of this.
The opposite.
Oh no, exactly. What did she do? They don't understand. We have to do it much harder. Push it, sell it, increase it. The fact that it doesn't work is going to get worse and worse. Well, that's too bad. We didn't notice that. Well, this is my whole message about management. and I've finished the first day with where I wanted to get to try and loosen up your thinking about this and see what really matters in this. Now, I'm not going to be so destructive in the next days. I'm going to try and build you a model of how to do this. But before I can offer that to you, you have to see why it is that our systems don't work, and you have to recognize that they don't. That's why the newspaper exercise. I want you to look at the newspaper and you will suddenly find, I guarantee tomorrow morning, I don't know what's in the newspapers, I'm not Merlin, I look like Merlin, but I'm not Merlin. You look at the newspaper, you will find examples lying all over the place of people who are trying to disobey Ashby's law because they haven't recognized it. You know, it's that simple. It's awfully simple. All great ideas are simple. In fact, the only opponents of cybernetics, some of my dearest friends among them, say that the trouble with Ashby's law is that it's a tautology. It's obvious and doesn't tell us anything. Well, I have tried to introduce it to you in a way whereby you can see that it does tell us something. Of course it's tautologous. The whole of mathematics is tautologous. If it weren't, it would be wrong. Doesn't mean to say it's useless. Does it? Now, I kept meaning to time myself. I didn't even bring the clock this time. How are we doing?
We're still running.
Well, we better stop. Now, I want, as I told you before, I want you to think about what I've said, sleep on it, talk to me in the morning, tomorrow afternoon about it, by all means. Look at the newspapers tomorrow. Look for validations, look for counterexamples, prove I'm wrong, whatever you like. Now, I also told you that I was going to give you a formal exercise. And I would like to end tonight by setting this exercise, and here it is, and I will dish it out, and you can spoil your night's sleep by trying to read that. But I want this recorded for the cameras, and I'm going to ask Kate Bailey if she would be kind enough to read it, because she has such a mellifluous voice. Sort this one out if you can, folks.
An exercise in what? The problem. You have been appointed manager of a shop engaged in jobbing production and have been finding out the form, which is pretty awful. Some shifts go well, but on others 2 types of difficulty arise, either separately or together. One difficulty is that a shift may throw up a loss compared with standard. The other is that a dissident faction of work people may decide to cause trouble, and that consumes too much energy in handling the wildcat strike threat. It turns out that there are 2 matters under your control that bear on this. Some work attracts a bonus rate, and the loading of this work can be manipulated. It seems to be generally accepted on the shop floor that more than 30% bonus work is good, while less is bad. There is another, an unpleasant kind of job, which you can always run or not. This, according to agreements, involves a flat 10% extra payment for the whole shift. The production director has said that when you start on Monday, you must operate this system as best you may. But until delicate negotiations at a higher level are completed, he would like to see as little trouble as possible. So you set to work to discover what actually happens, and it follows a definite pattern. If there is smooth working, i.e. no dissidence on a shift, it will continue on the next shift, unless the proportion of bonus work is bad. Then there is trouble, unless it is clear that the previous shift made a loss, in which case the troublemakers make no headway because the earlier loss realistically explains the bad bonus. Indeed, if the bonus is good following a loss-making shift, trouble will certainly break out while people argue what the management is up to. If there is trouble on a shift, then that too goes on into the next shift, even when the bonus is good and the extra payment is made, if the first shift made a profit. But there is an interesting exception to this. If the extra payment work is not put in, this seems to be taken as a sign that the order book is falling and that men may be laid off, At any rate, the trouble stops. When the trouble shift also makes a loss, then this weakens the dissident's hand, and there is no trouble on the next shift, provided that the extra payment work is put in. Given a profitable shift, the dissidents will see to it that the next shift makes a loss, unless there was also trouble on the first shift. In that case, troublemaking is apparently too dangerous, because it doesn't happen, unless both the bonus is bad and there is no extra payment, when the dissidents will get away with troublemaking again. After a loss-making shift, on the other hand, the next shift turns out to be profitable, so long as there was no trouble on the first shift. These dissidents are very careful. If there was, the loss will certainly continue. However, this whole situation is inevitably reversed if the extra payment is not made. Again, this seems to be taken as a dangerous sign in some circumstances, if not others. It's all terribly complicated, and your hands are tied. So this is certainly not an exercise in industrial relations. You must not interfere with those, but you do have a guarantee that the shop floor will respond true to form. What is this an exercise in, then? Can you solve the problem? Is there anything you can do to ensure making a profit and have smooth running as well? Tell you this much, we can work out from the state of affairs on the last shift Friday night that your first shift on Monday morning is bound A, to be in uproar, and B, to make a loss. Congratulations on the new job. And if it sounded as if I understood that, I assure you I don't.
Beautifully read, Kate. Thank you very much. I wrote it. It's a muddle, isn't it? Now, you see, this is trying to propose to you the muddle of real life. Now, what is an exercise in? You could tell me that already. Yeah, exactly. It's an exercise not in accounting or man management, because that's all taken out of it. But it's still very complicated. It's an exercise in complexity. Does anybody think if they sit down hard and work on that, they can solve it?
If I could, I'd have done it at my company.
Well, I always put this to my undergraduate students, and I offer a bottle of wine to the first person to give me the answer. And every year for 5 years, somebody's done it. So there's a challenge for you.
Do we get?
Oh, yes. Oh, yes. Yeah. Now, what I'm going to show you in the course of the days, as a sideline, as it were, is how to solve this, because obviously there are going to be ways, by looking at this cybernetically, systemically, that you can solve it. But I would quite like you to try, if you're willing, just to try and get the feel of it. And tomorrow I will explain more about it. But please join the fun. Because I'm not doing this to penalize you or be vindictive or something. I want you to see that real life is very complicated. And that sounds very complicated. It actually isn't, you see. So the question is, can you spot it? And if so, how? And are there techniques that would improve the matter? There are. Good night.